let's get started. So my name is Patrick Oli. I'm a Kubernetes contributor, reviewer, approver, but I'm also human. I make mistakes. One thing that at some point I noticed is that Kubernetes is not taking full advantage of all the different tools that the Go ecosystem offers to help us poor humans write better code. And I started investigating what we can do in Kubernetes to take advantage of this technology that's out there that other projects are using, and Kubernetes, for various reasons, currently doesn't. You are all, I think, Kubernetes contributors, so you may have seen an email that I sent to the dev mailing list about this. In this talk, I'm going to summarize quickly where we are, what my proposal is, and I also wanted to use the opportunity to walk you through some of the issues that are not currently found by our linting in Kubernetes. And I do have an idea of how we as a community of fellow developers can decide about how to move forward. There is a GitHub issue where after this talk, you probably all can start voting on individual checks that you would like to see enabled in Kubernetes. And in the second half of this talk, I'm going to show some examples just to get you started, because this is not something that I or anyone else can push alone. It's all something that we need to reach some kind of consensus. And I hope with this talk, I'm glad for the opportunity, we can perhaps reach some of this consensus. So a short introduction, if you haven't seen this tool yet, Golang CI lint is really excellent. And we're not taking full advantage of it in Kubernetes. We do run it. The pull Kubernetes verify runs some checks with Golang CI lint, but not at all the things that are typically enabled in the default configuration. It is a meta linter, so it runs different linters in the same process. It makes it fast. It has a unified configuration file. It's a really excellent tool. And the things that I found in other projects is that the default configuration is a fairly sane selection of things that make sense in Go code. It's vetted by the community, by other maintainers. Things don't get enabled if they are opinionated, but the default makes sense. I ran the default configuration against Kubernetes, and the existing code had lots of issues flagged by things that wouldn't fly in other projects, but we have it in our Kubernetes code base. There are over 2,000 issues found roughly in 60 categories, 60 different kinds of checks that fail in the Kubernetes code base. And we basically also give a bad example to new developers. I learned Go 5 years ago by studying the Kubernetes source code. And then gradually over time, I realized that some of it is really just bad code. For good reasons. Perhaps the checks didn't exist at the time. It was written by new contributors. Perhaps mistakes were made. But I probably picked up a few bad habits by just learning Go with looking at the Kubernetes source code. So how can we pave the path for new contributors? How can we make our own life easier in the future? Can we do something with better linting? So here's my proposal. We can't fix 2,000 issues all at once in the Kubernetes code base. That's clearly problematic. It also would be a lot of code churn that's not desirable. But what we can do is we can be more strict when we look at pull requests. And that's supported by Golang CI lint. There is a mode where you can instruct it to only flag issues that are in code lines that are modified or new in a pull request. And that way we can basically raise the quality bar of new code going into Kubernetes. The advantage clearly is higher code quality. Over time, as code gets rewritten or contributed for the first time, the new code will be better, according to some decisions that we still need to make about what is better, but that's the other part. Then, as code still evolves, it will also affect us. Our old code also will become better because it might be touched. It's also the disadvantage of this approach. You are perhaps, say, I don't know, updating one function in a larger code block, and suddenly you are modifying code that doesn't pass the linting anymore for a completely unrelated reason, not for the change that you are actually making. And if we're strict about this, it now will become your job to fix some mistake or fix some code pattern that was already in the code base, which can be annoying. It's particularly annoying if you are trying to fix a problem that is supposed to be backported. Say, I've seen that in one example. There is a deprecation warning that was added fairly recently, and it exactly hit one code line that was supposed to be backported. And I think the backport wouldn't be possible if it had used the new function instead. So, yeah, how we handle that is still a kind of open question, but I think there are mechanisms. For example, in the case that I just mentioned, if you need to make a change that would fail the new linting process, you could still have an exception in the code base. You could say no lint this particular thing, and you would be able to merge it, perhaps with a to-do remark that says, this is not good, we need to come back to this in the future, but there are ways to do that, so it would be possible. And I've been working on this for a while. I actually talked to people about this at KubeCon Europe last year, and I've done experiments since then. One of the key things that we have now, and this is the current status, so if you check out Kubernetes master, right now you can already do stricter linting with files in the Kubernetes code base. The entry point is in the hack directory. There is a Golang CI YAML file. That's the one that is used by the existing code. That's what we currently run as part of pull Kubernetes verify. But there's the second configuration file that has all the same checks as the normal one, but also enables the default configuration. At this point, my goal was just really be as consistent with normal Golang CI lint as possible. I've not made any personal choices myself whether I prefer a check or not. It's all basic Golang CI lint default configuration plus some things that Kubernetes had already enabled. You can, as a developer, when you're working on source code, you use the verify script that we have in the hack directory. Not sure how, well, it's large enough on that screen here. So the verify Golang lint script has some very simple, shell script has some simple flags. One is -s, and that enables the strict linting. It basically just chooses the different configuration that I just mentioned. And then it will check the entire code base. That's how I found these 2,000 issues. Probably not something that you want to do yourself, unless you're really curious. What you can do instead, if you have checked out a branch and work on some new feature, you can add another parameter, -a for automatic, and then it will enable this additional mode in Golang CI lint and only tell you about code that you have modified in your branch. That corresponds to what would happen with a proposed linting or stricter linting of pull requests. And then this is something that you can do now. Then it's entirely up to you which of these issues you find worth fixing. It's perhaps something to recommend to new contributors, people that are just getting started with Go code. So this is already possible. It's available. We just need to tell people about it and get it used more often, perhaps. And for the CI, there is a brow job. It's not enabled and not started by default. So you need to use this magic test pull Kubernetes verify strict lint command to trigger it in a pull request. I've done that a few times when code looked suspicious, but I wasn't sure. So you can just run it. Also, if you get a pull request from someone who is not a Kubernetes contributor yet or member yet, community member, his pull request will not get tested. And I think this is a good job to just get started to see whether it even compiles, whether it has any obvious issues. And you can do that while the pull request doesn't have the OK to test yet. So you don't need to kick off all of the different pro jobs on a suspicious PR. You can just start one, like this one here. And that's something that you need to remember when you are a contributor or a reviewer, approver, because as I said, it's not going to start immediately if we keep it in the current state. Then the job is configured to be not merge blocking. So all of the issues that it finds can essentially be ignored. You will have one failed job perhaps, but it will not prevent Tide from merging the PR if you later find that you don't want to fix these issues. And that's totally fine, because as a community, we haven't really decided yet whether these are things that are worth fixing. The results of that job are in the Prowl output, like in any other Prowl job. Unfortunately, it would be much nicer to get them as GitHub annotations, but I'll get to that. So right now, the experience is, like with any other things, you need to teach new contributors to look at the test jobs, not just automatically and reflective, without thinking about it, do a retest. It won't fix these things. These are not flakes. If it fails, it fails. It will always fail. So you need to look at the brow job and really read text output to see why it failed, which is a bit annoying, which leads me to the next steps. So when I started looking at this, I found an old issue that was originally about GitHub Commons, and annotations are similar. It's the same problem essentially. For various reasons, we are not using GitHub Actions. They didn't exist yet. We are Prow-based, we run things in Prow, and then we somehow need to report back the result to GitHub. It would be much nicer in this case if we could do it like in any other modern Go project that runs on GitHub, where the result of these different issues get posted as annotations, because then you can look at the source code that was modified. You will see additional hints on the different lines that have issues, and it's much easier to discover what's wrong and where it's wrong. But as I said, we don't have that in Kubernetes at the moment. This one issue is about a design for comments, but it's also could be used for annotations. I just learned this morning from Rajas Kaduras that he is there, hello. he's available again to work on this. He kind of tried to do it last year, but then got distracted, and for good reasons, can't blame him. It's just that we still, after talking about it at KubeCon Europe last year, we still have this open issue that we may be able to have something, say, in a month. So keep that in mind when we think about next steps. But maybe in 1 month from now, we may have this feature. It is important when we decide about the configuration, because Golang CI lint has a feature where it can set the severity of an issue. We could have it configured for some checks so that it's really just an annotation. It's not, doesn't need to be fixed. It's like a nit. It's a good hint that this code line might be improved, but it doesn't need to be. But if we configure all of these checks in this mode, the end result would be that this brow job will just pass. It has to, otherwise we can't make it merge blocking, or we basically would just have to rely on people reading the text output to find these nits, and no one will do that. So we are currently kind of limited with what we can do in our configuration. It basically has to only be issues that we really care about that need to be fixed. We can't do this intermediate level where we just point them out, because we can't have no good way of pointing them out in the fact in the UI of GitHub. But perhaps from 1 month from now we will have. So it's a viable option. And that is actually, I think, the second half of my talk is about all of the different configurations or checks that we could enable. And what I've done is I've created this one GitHub issue that you see linked here. I went through all of these 2,000 issues. No, I used shell scripts. So I summarized a little bit, and I've posted for each of the 60 categories, I posted one comment with one example. And I just randomly picked The first thing that Golang CI-lint reported in that category, and I copied that here, it's actually a source code link. So we can see that this particular line here doesn't have error checking. And it's a common problem. I've summarized how often I found these issues, and I think missing error checks were the most common ones, with 512 occurrences counts in the entire Kubernetes code base. This is perhaps a good example of things that get found, but it's also a bad example in the sense that you can't really do much in this particular code line. So that highlights a key problem that we have to decide about. If we enable some of these checks, it will be annoying in some cases. Like adding error checking here doesn't give us much. It's in a defer call. So yeah, all you can do is you could log the error, or you can just suppress it by assigning it to the underscore capture thing. But at least you need to point out in the source code that you don't do error checking. So that would be already a step forward, I think. But then there are also other cases that definitely need error checking and don't have it today. And that's hard to find when you do code reviews. You have to remember that the function returns an error and that an error check is missing. You have to basically know quite a lot and keep it in your head when you do reviews. This could be done by a tool, much easier than it is done by humans. So just to finish the thought that I had earlier about the decisions that we need to make. So we can basically say we don't care about an issue. We ignore it completely. Let's assume that we can make it in it. We just warn about it. We can make it merge blocking and say that new code must have this fixed before it gets merged. And finally, we can decide that some of these things are so severe we should fix it in existing code. Perhaps not all at once, but at least we should have tracking issues and eventually get these code fixed also in Kubernetes itself. And that's what this voting is about. So I encourage you to go to this issue, look at some examples. I think my instructions are that we can assume by default that we will make it merge blocking. So if we don't get any other different opinions about an issue, let's just make it merge blocking and see how that goes. We can still adapt that choice later on. If a pull request finds that it doesn't get merged because of a linter warning that is perhaps incorrectly too severe, we could just adapt the level of that particular issue in that one PR and change our opinions over time. Yeah, I think that's it about this issue. And I'll also send out an email to the dev mailing list again, so that not just people here in this room get to decide, but also all the other contributors have a chance. And we can let this run for a while, perhaps a month. And then one month from now, we can reconsider and perhaps take the next steps. Okay. Sorry? Okay, the next talk gets the full time. I gave one example. I'll do the last example. There are others here. I'll finish with this one here because I'm allowed to make fun of the Kubernetes contributor who wrote that code. It's not a common issue. It's a bogus or sloppy lang call that is compared larger or equal 0, which is always true. So who wrote that? Well, it turns out it was me. And it has passed reviews. Someone else didn't pick it up either. It's not fatal in this case. It's not really a bug. It doesn't make a difference. But it is wrong code, and it should be fixed in the tree. And I will do that after the call. Thanks.